Alright, exam 1, problem 6. We have power supply that turns on at t equals 1 and turns on for 1 second with voltage of 10 volts. Internal resistance of the power supply is 100 ohms and it's connected in series with a 100 ohm resistor and a 1.2 millifarad capacitor. What is the voltage across the capacitor at t equals 0.5 seconds, and what is the voltage across the capacitor at t equals 1 second? Okay, so we have the resistance, we have the capacitance, we have the target voltage, we have times. So first part is, what is the resistance, right? The resistance, you have to add the internal resistance and the external resistance, right? So the total resistance we're dealing with is 200 ohms. The time constant we're dealing with is RC, is that 200 ohms, right, times 1.25 millifarads, right? So 200 ohms times 1.25 millifarads. 1.25 millifarads, milli is 10 to the minus 3, so this is 0.25 seconds, right? The time constant is 0.25 seconds. All right, so the question is, what is the voltage reached in part A at 0.5 seconds? Well, we know that the voltage is V naught, 1 minus e to the minus t over RC, right? So we have here V equals 10 times 1 minus e to the, all right, at 0.5 seconds, we've got minus 0.5 divided by 0.25, right? So this is 10 times 1 minus e to the minus 2. All right, 10 times 1 minus e to the minus 2. Okay, so 1 minus, I'll just go over and do the whole thing. 1 minus e to the minus 2 is 0.64, right? And so times 10 volts is 8.65. I don't know what's going wrong there. Equals 8.65 volts. Okay, I'm just going to have to live with that. All right, so we get to 8.65 volts at the 0.5 second mark. Now, part B, right? Part B, we're now at 1 second. And so this is going to be at 4 time constants, 1 minus e to the minus 4, right? And so 1 minus e to the minus 4, I'm just going to go here and I'm going to stick in a minus 4, and it's going to propagate through, and we got 9.82 volts. 9.82 volts. And that is it for problem